Till now, we've done examples on limits. I mean, we've done two examples. Yeah, two examples on limits in which we factored them out. We solved the limits algebraically. See, but that's not always the case, right? Let's say that I give you a function, f of x, and assign it the value 1 over x. Yeah? And let's say then I ask you to find the limit as x approaches 0 of f of x, right? So clearly put the value of 0 into this expression and you get not defined, of course. And if you see this expression carefully, we can't factor it out, can we? 1 upon x. If we can, well, then I don't know. But according to me, we can't factor it out. And I'm sure you also might get the thing that we can't factor it out, right? So these kind of questions we solve using graphs or we solve numerically, which we will be telling you. But in this video, we're going to tell you about graphs, right? One-sided limit from graphs. So for these cases where you don't get the limit algebraically, you make a graph. I mean, in some questions you might already get a graph, but over here we're going to make a graph. Okay. So let's say this is my graph. This is the f of x axis. This is my x axis, right? And now we're going to plot this expression 1 over x, f of x is equal to 1 by x on this graph for values of x. So x equal, let's say 1, 2, 3, 4, 5. Negative 1, or I'm not going to make negative in this video, I'm going to keep that for next video, and I'm going to go positive in this direction. 1, 2, 3, 4, 5, 6, 7. You might be seeing that I've only made the positive. I've not made it using on the minus x axis or the minus f of x axis, because in this video I'm only going to discuss the positive side, because this is on one-sided limits, not the complete limit, as you might say. So first let's put values 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7. And now let's take this expression f of x equals 1 by x. So if we find the f of 5, we get 1 by 5, which is equal to 0.2. If we find the f of 4, we get 1 upon 4, which is 0.25. If we find the f of 3, we get 1 by 3, which is 0.6 bar. If we find the f of 2, we get 1 by 2, which is 0.5. And if we find the f of 1, it is obviously going to be equal to 1. And I think I should just select this thing, maybe copy it and then delete it, yeah, and paste it right here, outside the graph. Yeah. So now so let's try to put the values. So if f is 5 right here, f of x is 0.2. 0.2 would be like, let's say this is 1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, no, 0.1, and then one more point. So 0.2 would be right here, somewhere just above right here. 0.25 would be a very little above this point right here. 0.6 would be somewhere here. 0.6 repeating, I mean to say, sorry, this is 0.3 repeating. 0.3 repeating, I'm sorry. 0.3 repeating would be somewhere just make this 0.3 repeating. I'm sorry, I made it 0.6 repeating. 0.3 repeating would be right somewhere right here. 0.5 would be right here. 1 is here, right? And if you try to take the like f into decimals, so if we say f of 0.01, then we would get it that it equals to 100, because 1 upon 0.01, it gets the 100. 100 would be right, so we just shifted it and 100 goes right out of the graph, right? So what we're doing in this case is that because when we inputted the value of x as 0, we got it not defined. So what we are doing is we are approaching 0 from the positive direction, right? We're approaching it from the right side. So we're going to put values of x closer to 0. You can try to put more values, 0.0001, 0.000001. It's your choice. What you would see is if I just join the points. Whoa. Not my best joining attempt. But what you would see is that you would get a graph something like this, right? A graph. I'm not drawn the best of graph. It goes something like this. This is better. Yeah, this is just not so good. I think I should draw it again. I think I should. Maybe yes. This point is somewhere right here. The graph would be something like this, right? Yeah, this is better, but not the best. So this graph would head towards infinity. You can see that. So this can be written in notations of limits as this. So the limit as x approaches 0. We approach 0, right? But we approach it from the positive direction. So we put a little plus over here. This doesn't mean the positive 0 or negative 0, right? Or if I had a minus 1 over here, you couldn't say that it's a 1 or a minus 1. This just shows that it doesn't show the sign of this 0. It shows the sign from which direction are we approaching 0. So this shows that limit as x approaches 0 from the positive direction of f of x. The limit of f of x as x approaches 0 from the positive direction. We're seeing that it's heading towards infinity from the graph. We're seeing that it's heading towards infinity. So this was one-sided limit. We approached 0 from one side. And in the next video, we'll be approaching 0 from the negative direction.